For almost a century, submarines have patrolled the world's oceans. Their missions, even their construction, cloaked in secrecy.
188, HFSB 11. 400 feet coming 800 feet.
A showpiece of revolutionary design and construction techniques. The nuclear-powered USS Seawolf takes its place in the ocean as the most advanced and lethal submarine ever created.
Report 080.
It's taken over 3,000 workers more than a decade to build what the Navy calls the most complicated machine on Earth. The crew of Seawolf has endured years of training to earn a place aboard this mechanical marvel. She is a prototype for the Navy's undersea future. But before they can claim the title of sovereign of the ocean, man and machine must pass a complex and dangerous series of tests known as the sea trials.
And battle station.
Sierra 3-2, a submerged contact. My intentions are to engage this contact and stay course 120.
The stakes could not be higher. In the post-Cold War era of budget cutbacks, the Navy is relying on Seawolf to prove it can do more with less.
Contact Sierra 3-2.
If this ship fails her sea trials, the entire future of the Navy submarine program will be affected.
Firing point procedures.
The 14 officers and 124 enlisted men of Seawolf are well aware that they and the submarine's builder are under intense scrutiny.
Shoot on generated bearing.
The number of Seawolves approved for construction has already been slashed from 30 to 3. Workers at the electric boat company who built Seawolf have seen their numbers drop from 25,000 to 7,000. To them, a successful sea trial could mean the difference between economic life and death.
Very well, steady course 050. 050 online. Chief of Watch, stand down from battle station.
But as the world's most sophisticated weapon slowly descends beneath the waves, the ultimate test will come from the ocean itself. At bone-crushing pressures deep below the surface, there's no margin for error. There are few places in the world large enough and sophisticated enough to build a nuclear submarine. This is one of them, the Electric Boat Company's machine shop in Quonset Point, Rhode Island. For the first time ever, the company has allowed cameras inside to witness the birth of a nuclear submarine. Here, giant pipes are twisted into intricate shapes, while massive grinding machines polish tons of special metal alloys into parts that will become the body of Seawolf. When Seawolf was designed in the 1980s, the computer revolution was just beginning. With the advent of computer-assisted design, or CAD technology, her creators could drastically reduce the staggering amount of hand calculations required. Now, basic design measurements such as length and diameter could be visualized in ways the early pioneers couldn't imagine. But the design process was still full of challenges. The three main problems facing modern Navy designers today were also faced by their forefathers. First, how to create a vehicle that could stay underwater for extended periods of time. Then, how to install enough weaponry to make it a viable threat. Finally, how to remain undetected. In the past, submarines were constructed by welding together steel plates to form the hull. Then the machinery, or guts of the sub, would be lowered inside through openings in the top. This was the primary method of submarine construction from World War I through the Cold War. The Cold War was one of the most volatile and dangerous times in American history. As the arms race between the United States and the Soviet Union escalated, the government turned to its undersea force for defense. The Navy developed two kinds of submarine classes, the ballistic missile submarine and a smaller class of subs, the attack class. The ballistic subs, often called boomers because of their enormous firepower, were essentially large mobile platforms for launching nuclear weapons.
3, 2, 1.
Deployed on secret missions throughout the world's oceans, the ballistic missile submarines served as a threatening deterrent to an enemy first strike.
Weapons gone. You have permission to fire.
We note 1.
Their companion class, the attack subs, were smaller and faster than the boomers. These subs were designed to do exactly what their name implied: attack, quickly, silently, and with deadly force.
Shoot.
Following the Cold War, the threat of a superpower conflict decreased, while the likelihood of smaller, regional conflicts increased. In response, a new kind of submarine was needed, a submarine like Seawolf. For this new class of submarine, a new building approach was employed. The Navy created Seawolf using a modular construction method. For the first time, a submarine would be built as a series of modules, with the piping, machinery, and fittings installed at the same time. This hull cylinder, about 40 feet in diameter, is about to become part of a larger, complete module. Using this new method of construction, the hull will not only be much stronger, but maintenance on the sub will also be easier. In the past, engineers would have to cut holes in the pressure hull to add or remove machinery. This time-consuming, labor-intensive process required extensive recertification tests. Now, machinery can fit through special openings that are covered by a watertight hatch, increasing the efficiency of the construction process and the strength of the hull. Even a pencil-sized puncture in the ship's hull would bring in water with the velocity of a bullet fired from a rifle. To learn how to survive against such impossible odds, the crew must now face their own certification process. That training begins here at the Naval Submarine School in Groton, Connecticut. These trainee submariners know that someday they may face a situation of life and death, an emergency in which their response will either save the ship or send it to the bottom of the sea.
For the water and enter them lower level bills. Enter them lower level DC Central Live.
During World War II, submarine crews in the Pacific faced impossible odds with terrifying regularity. Under constant attack from Japanese depth charges, submarines became the final resting place for thousands of American servicemen.
Coming on, fire 1.
Despite the losses, American submarines inflicted major damage on the Japanese Navy and merchant fleet. One after the other, these steel sharks rolled out of shipyards as fast as they could be built. In response, the Japanese tried every possible method to turn back the U.S. subfleet.